Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. My name is Alina Rahayu binti Muhammad. The title for my project is Torrefaction of Leucaena Leucocephala in a fixed bed reactor for an improved calorific value. Okay, this presentation will cover on research background, problem statement, methodology, and novelties. Firstly, let's look at the Leucaena Leucocephala tree. Okay, it is easily growth in Malaysia and especially in the northern region of Peninsular Malaysia, which is Perlis. There are a lot of Leucaena tree as it is a fast-growing tree. Leucaena Leucocephala is also known as Petai Belalang among the village folks. Leucaena trees are growing very fast at 44% from the first month of planting to the fourth month, and after 12 months, the trees has towered, reaching to a height of more than 3 meters. Okay, therefore, the problem with Leucaena is that it has high moisture content with low calorific value. Therefore, this is the major challenge for it to be utilized as a solid fuel. However, this can be overcome by undergoing the torrefaction process. Because this process, it can reduce the moisture content but improve the calorific value. Once the calorific value can be improved, therefore, Leucaena leucocephala can be considered as a potential solid fuel. The process is actually heating of the biomass, any biomass, okay, slow heating of biomass within the temperature range of 200 to 300 degrees C at a certain holding time under nitrogen atmosphere or without the presence of oxygen. Now, torrefaction process, upon torrefaction process, the torrefied biomass, okay, therefore it would have a low moisture content with a higher heating value, with an improved heating value. Okay, so methodology for the process is firstly, of course, preparation of the raw material, physical pretreatment, okay, whereby the biomass which is obtained from the nearby village, which is bring to the lab, is cut, okay, manually, and it will undergo some proximate analysis by ASTM method. Okay, once we have biomass of a certain range, particle size range, for example 250 to 500 micron size, therefore we can perform torrefaction on the biomass, and the calorific value of the raw and torrefied biomass can be obtained, okay, can be obtained using the bomb calorimeter. Now, how does the torrefaction process is conducted? Please look at the figure on the left hand side there. Okay, we have a nitrogen tank on the left hand side. Now, initially, okay, before torrefaction process is begin, biomass is located inside the reactor. You see the tubing reactor there. Biomass is located there, about 6 gram, and glasswood is located just below the biomass, okay, to make sure that the biomass sits on its place. And once it is ready, okay, the setting of the temperature, the final torrefaction temperature is using the final temperature is set using the Shimadan light program, okay. So initially the nitrogen gas is purged from the tank that flows through the flow meter at a certain flow rate, for example 150 milliliter per minute, okay. So it passed through the tubing reactor, okay, and it creates that inert environment, inert atmosphere. This is significant because we don't want any combustion process to occur, but we want the torrefaction process. Okay, so once the temperature is set, for example, at 200 degrees C at a rate of at a heating rate of 20 degrees C per minute. So the temperature increased from room temperature to 200 degrees C, okay, and the biomass undergoes some changes, okay. Some of the vapor comes out from the biomass, okay, it comes out. So because the nitrogen is purged from the top there, therefore the volatiles are swept away, okay, swept away through the condenser to the cooling unit. Okay, so some of the bio oil is condensed in the flux in the cooling unit, and the non-condensable gases are released to the atmosphere. Now, the torrefied biomass is obtained inside the reactor. So once the heating rate, okay, once a halting time is reached, for example, for 20 minutes, so 20 minutes or 60 minutes, so therefore the reaction is stopped and the torrefied biomass, okay, is measured, okay, is record the measurement, the weight of the biomass is measured and the mass is recorded. Okay. Now this is the physical appearance of the raw and torrefied biomass at different temperature. For example, 200 degrees C, 220, 240, 260, 280, and finally 300 degrees C. As you can see, once the torrefaction temperature is increased, the light brown color of the raw biomass, okay, start to change to dark brown, okay, and darker brown, and then finally black at 300 degrees C. Now, this is the calorific value, okay, of the raw and torrefied biomass, which is experimented using bomb calorimeter. Now, as you can see, the raw biomass has the calorific value of about 17.5 megajoule per kilogram. Okay, so once torrefaction is performed on the raw biomass, on the raw Leucaena Leucocephala, okay, the torrefied biomass at 200 degrees C, 220, 240, 260, 280, and 300 degrees C, this torrefied biomass are measured the calorific value, and it is as shown there, the calorific value increases once the torrefaction temperature increases. So therefore, we can see that torrefaction process has improved the calorific value of the biomass, because the value increased from about 18 at 200 degrees C to about 20 at 220 degrees C. Okay, this increases further to 30 megajoule per kilogram at 280 degrees C, and at 300 degrees C, the calorific value increased further to about 34.5 or 35 megajoule per kilogram. Therefore, we can conclude here that the calorific value has increased at increasing torrefaction temperature. Now, novelty on the torrefaction process is that it is a simple processing at moderate temperature, which is at temperature 200 to 300 degrees C. It is a green process because only bio-oil, torrefied biomass, and biogas are produced. And this process does not use hazardous chemical or produce hazardous waste. Now, novelty of torrefied biomass. Torrefied biomass has low moisture content with high calorific value, and has a modified structure that this improves its grindability. Okay, thank you very much, and Assalamualaikum.